The Ship of Theseus, Identity Paradox. Imagine a ship that has been sailing for centuries, but over time, every single part has been gradually replaced. Is it still the same ship? This ancient paradox strikes at the heart of how we understand identity and continuity through change. The paradox deepens when we consider a twist. What if someone collected all the original replaced parts and built another ship? Which one is the real Ship of Theseus? The one that maintained continuous existence but has all new parts, or the one built from original materials but assembled later? This seemingly simple puzzle reveals profound questions about identity. It applies not just to ships, but to our own bodies, which replace cells regularly, organizations, and even our sense of self. Are you the same person you were a decade ago when most of your cells have been replaced? The most fascinating aspect is how it challenges our binary thinking about identity. Perhaps identity isn't an all-or-nothing property, but exists on a spectrum of continuity and change. Like a river that's never the same water yet maintains its identity, maybe the essence of something lies in its pattern rather than its components. The Grandfather Paradox, Time Travel. Imagine traveling back in time and preventing your grandparents from meeting. If you succeed, you would never be born, but then, how could you have traveled back in time to prevent their meeting? This mind-bending paradox exposes the logical contradictions inherent in time travel. The paradox reveals deeper questions about causality and the nature of time itself. It challenges our linear understanding of cause and effect, suggesting that time might be more complex than our everyday experience suggests. If time travel is possible, how does the universe resolve such logical impossibilities? Scientists and philosophers have proposed various solutions, from parallel universes to self-correcting timelines. Some suggest that any attempt to change the past would be mysteriously thwarted, creating a consistency protection mechanism in the universe. The most profound implication is how it forces us to question our fundamental assumptions about time, free will, and causality. Like a cosmic game of chess, where every move must maintain logical consistency, it suggests that reality might have built-in safeguards against paradoxes.
Click subscribe to this channel to get more topics you love.
The Lear Paradox, Self-Reference. Consider this simple statement. This sentence is false. If it's true, then it's false. But if it's false, then it's true. This ancient paradox has puzzled logicians for millennia and reveals the strange territory where language turns back on itself. The paradox emerges from self-reference combined with negation. It's like a snake eating its own tail. The meaning keeps circling around without finding stable ground. The statement creates an endless loop of contradiction that seems to defy the basic laws of logic. What makes this paradox particularly fascinating is its implications for truth, language, and computation. It has influenced everything from mathematical logic to computer programming, where self-referential loops can create similar logical impossibilities. The most profound aspect is how it exposes the limitations of formal logical systems. Like finding a crack in the foundation of reason itself, it suggests that some concepts might be inherently paradoxical, existing in a state of perpetual contradiction. Zeno's paradoxes, motion and infinity. Zeno's paradoxes argue that motion is impossible by showing that to reach any destination, you must first travel half the distance, then half of the remaining distance, and so on infinitely. Since there are infinite points to cross, how can movement ever occur? The genius of these paradoxes lies in how they use infinity to make the ordinary seem impossible. They force us to confront the gap between our mathematical understanding of infinity and our physical experience of motion. How can we complete an infinite number of tasks in a finite time? Modern mathematics has provided tools to resolve these paradoxes through concepts like infinite series and limits. Yet the philosophical implications remain profound. They question our understanding of continuity, infinity, and the relationship between abstract mathematics and physical reality. The most fascinating aspect is how these ancient puzzles anticipated modern discussions in physics about space, time, and the nature of reality. Like a bridge across millennia, they connect ancient Greek philosophy with quantum mechanics and the structure of spacetime. The Fermi Paradox, extraterrestrial life. Given the vast number of galaxies, stars, and potentially habitable planets in the universe, intelligent life should be common. Yet we see no evidence of it. This silence, this cosmic emptiness, is what physicist Enrico Fermi found paradoxical. The power of this paradox lies in its simplicity and implications. The numbers suggest we should be swimming in alien signals and evidence of extraterrestrial civilizations. The fact that we're not either challenges our assumptions about the prevalence of life or suggests something profound about the nature of technological civilizations. Various solutions have been proposed, from the possibility that advanced civilizations destroy themselves to the idea that we might be living in a cosmic zoo or simulation. Each potential answer carries deep implications about our own future and place in the universe. The most profound aspect is how it forces us to confront our cosmic loneliness and the potential paths of technological civilization. Like a mirror reflecting our own future, it raises questions about humanity's ultimate fate. The paradox of choice, decision-making. While we tend to think more choices lead to greater happiness, research shows that too many options can actually create anxiety, dissatisfaction, and paralysis in decision-making. This counterintuitive finding reveals deep truths about human psychology and happiness. The paradox demonstrates how our intuitive understanding of freedom and satisfaction can be flawed. When faced with too many options, we often fear making the wrong choice, experience decision fatigue, and end up less satisfied with our eventual selection due to wondering about the alternatives we didn't choose. What makes this paradox particularly relevant is its application to modern life, where we face an unprecedented number of choices in everything from careers to consumer products. It suggests that the abundance of options in modern society might actually be contributing to anxiety and unhappiness. The most sophisticated aspect is how it challenges our fundamental assumptions about freedom and satisfaction. Like a wise friend suggesting that less might be more, it invites us to reconsider what truly leads to contentment and well-being. The Bootstrap Paradox, Causality Loop. Imagine a musician who is inspired by an old recording to create a piece of music. They then travel back in time and leave that same recording, which becomes the inspiration for their younger self. Where did the music originally come from? This paradox presents a loop of causality with no clear beginning. What makes this paradox particularly fascinating is how it challenges our understanding of originality and creation. In this loop, information or objects exist without ever being created. They simply exist in an eternal cycle. It's like a literary story that writes itself, with no original author. The implications extend beyond time travel scenarios into questions about creativity, originality, and the nature of information itself. If something can exist without being created, what does that tell us about the nature of ideas and inspiration? The most profound aspect is how it questions our assumptions about cause and effect. Like an infinite mirror reflection, it suggests the possibility of existence without origin, challenging our linear understanding of creation and causality. The Barber Paradox, self-reference. Consider a barber who shaves all those, and only those, who do not shave themselves. Does the barber shave himself? If he does, he shouldn't, as he only shaves those who don't shave themselves. If he doesn't, he should, as he shaves all who don't shave themselves. This seemingly simple scenario reveals deep problems in logic and set theory. It's similar to asking whether the set of all sets that don't contain themselves contains itself, a question that helped revolutionize mathematical foundations. The paradox demonstrates how everyday language can create logical impossibilities when self-reference is involved. It shows that some perfectly reasonable-sounding definitions can lead to contradictions that cannot be resolved within the system. The most sophisticated aspect is its role in the development of mathematical logic. Like a small crack that reveals structural problems, it helped mathematicians understand the limitations and potential pitfalls in logical systems. The arrow paradox, motion and time. Zeno's arrow paradox suggests that if we observe an arrow in flight at any instant, it occupies a space equal to its length. At that instant, it's not moving because an instant has no duration. If it's not moving at any instant, how can it ever move? This paradox challenges our understanding of time, motion, and continuity. It forces us to confront whether motion can be broken down into static moments, or whether there's something fundamentally continuous about movement that can't be captured by looking at individual instants. Modern physics has interesting parallels with this ancient puzzle, particularly in quantum mechanics where position and momentum cannot be simultaneously defined with perfect precision. The paradox anticipated by millennia some of the strange properties of reality at its most fundamental level. The most profound aspect is how it questions our ability to understand continuous processes through discrete analysis. Like trying to create motion from still photographs, it reveals the potential limitations of breaking continuous phenomena into discrete parts. The unexpected hanging paradox logic. A judge tells a prisoner he will be hanged one morning next week, but the execution will be a surprise. He won't know the day until the morning it happens. The prisoner reasons that it can't be the last day, as he would then know. Then not the second to last day, as the last day is impossible, and so on until he concludes it's impossible. Yet it can still happen. This paradox reveals the strange interaction between knowledge, expectation, and certainty. The prisoner's seemingly logical reasoning leads to a conclusion that reality can easily contradict, suggesting something is wrong with the reasoning process itself. What makes this paradox particularly intriguing is how it demonstrates the limitations of logical deduction when applied to knowledge about future events. It shows how perfectly valid seeming reasoning can lead to false conclusions when dealing with self-referential knowledge. The most sophisticated aspect is its implications for epistemology and the nature of knowledge itself. Like a magic trick that works even after you think you've figured it out, it shows how our reasoning can be flawed even when it seems impeccable. The Omnipotence Paradox, divine power. Can an all-powerful being create a stone so heavy they cannot lift it? If they can't create such a stone, they're not all-powerful. If they can create it but can't lift it, they're also not all-powerful. This paradox challenges the very concept of unlimited power. The paradox extends beyond theology into fundamental questions about the nature of power and logical possibility. It asks whether the concept of unlimited power is itself logically coherent, or whether there are inherent contradictions in the notion of absolute ability. Some philosophers argue that the paradox is resolved by noting that omnipotence shouldn't include the ability to do logically impossible things. Others suggest it reveals deeper truths about the limitations of human concepts when applied to ultimate questions. The most profound aspect is how it forces us to examine our understanding of concepts like infinity, power, and logical possibility. Like a philosophical cone, it suggests that some concepts might break down when pushed to their absolute limits. The simulation paradox, reality. If it's possible to create perfect simulations of reality, and these simulations can create their own simulations, then the number of simulated realities would vastly outnumber the one real reality. Therefore, statistically, we're probably living in a simulation. This modern paradox, popularized by philosophers and tech visionaries, challenges our fundamental assumptions about the nature of reality and consciousness. It suggests that our entire universe might be a computer simulation run by a more advanced civilization. What makes this paradox particularly powerful is how it uses probability and logic to reach a conclusion that seems intuitively absurd, yet is difficult to disprove. It raises questions about the nature of consciousness, reality, and what we can truly know about our existence. The most sophisticated aspect is how it connects ancient philosophical questions about the nature of reality with modern understanding of computation and consciousness. Like a digital version of Plato's cave, it suggests our reality might be more complex than we imagine.